Welcome to a refresher lesson for quadratic functions, properties, and operations. This video corresponds to the examples on a worksheet packet that can be found at my Teachers Pay Teachers store with the same name. In this video, I will explain the skills and steps necessary to complete all of the examples on the worksheet. Please feel free to skip around to engage in the concepts with which you would like some help. So when we are dealing with quadratic functions, we need to realize that quadratic functions can take three different forms. The key to working with quadratic functions effectively is being able to change from one form to another, because different forms will point out different characteristics of the quadratic functions. So we want to be able to change a standard form into a factored form, or a vertex form into a standard form, depending on what we're trying to accomplish or what we're trying to find out about the quadratic function. So that's what this video is going to focus on, is how to change from one form to another and some of the skills necessary to do that. So let's start with a factored form being changed to a standard form. So you can see here we have a, then x minus 3, so that's an x plus p value, and then x plus 4, x minus q value. So we've got that form of being a factored form quadratic. We want to change it into standard. And so we're going to do that by using the FOIL method. So remember, FOIL is F-O-I and L. And these letters tell us how we should go about multiplying two binomials. So a binomial, remember, is just an expression with two terms. So there's one binomial and there's the other binomial. Those are the two things we're going to multiply together first. So we're kind of setting aside the two for just a moment and just focusing on the binomials. So the F in FOIL stands for firsts. And that means in the two binomials, we want to multiply the first terms together first. So we'll take the x from the first binomial times the x from the second binomial, and we'll get an x squared. Then we move to the O. O stands for outsides. So if we look at these binomials together as a unit, the outsides of this whole thing are this x and this 4. So that's what we multiply together next to get a 4x. Then we go to I. I stands for inside, so similar to what we did with outside. We're looking at the inside terms now, so that's the -3. And remember, if we have a sign here that's negative or minus, we keep that with the constant, so -3, and then this inside term of x. And so that gives us -3x. And then finally, the L stands for lasts. So the last terms in the two binomials are the -3 and the 4. And that will give us a -12. So at this point, we still have this 2 out in front, but now we're going to rewrite the product of the two binomials in more of a standard form by adding all of these terms together. So we'll have an x squared plus, we can combine our two x terms of 4x and -3x to get x, and then -12. And now we'll finish by distributing the 2 to all three terms that are inside of the parentheses. So 2 times x squared plus 2 times the x plus 2 times the -12, which will give us a -24. So this is our standard form of the same equation. It's an equivalent equation, just in a different form, where we have this 2 as our a value, this 2 is our b value, and the -24 is our c value. Now, if we want to change vertex form into standard form, we need to be a little bit more careful about the order we do things in, because we don't just have multiplication like we did in the previous example. We have exponents, multiplication, and addition. So we want to make sure we do things in the correct order. So if we look at our PEMDAS or BEMDAS, if that's what you're more familiar with, our first thing to look at is the parentheses. So we have this x plus 4 in the parentheses, and then we're going to deal with the exponent that's on that. So we are going to take x plus 4 and square it. Now you can do this by either using the pattern for a binomial squared, or if you don't remember the pattern, you can always change it into x plus 4 times x plus 4, because that's what x plus 4 squared means. And then you can just FOIL it like we did in the previous example. So either way, regardless of which method you decide, pattern or foiling, you are going to get an x squared plus 8x plus 16. Then we're going to take a look at any multiplying or dividing in the problem. Well, we don't have any division, but we do have multiplication by this 3 out in front. So our next step is to take that 3 times our previous result of x squared plus 8x plus 16. And again, we're going to distribute to all 3 of the terms inside the parentheses. So we'll have a 3x squared. 3 times 8 will give us 24x, and 3 times 16 will give us 48. And then finally, we need to deal with any adding or subtracting in the problem. Again, there's no subtraction, but we do have this addition of 5. So starting with our previous result again, 3x squared plus 24x plus 48. To that, we will add a 5, which means we're looking at 3x squared plus 24x plus 53. So our final answer, now in standard form, and again, equivalent to the vertex form we started with, but now in standard form, it will be 3x squared plus 24x plus 53. The 3 is our A value, the 24 is our B value, and the 53 is our C value. Now, what if we want to go the other way? What if we want to start with standard form and change it into factored form? Well, our approach is going to depend a little bit on whether our A value is a 1 or not a 1. Now, if you look at this example, we're asked to rewrite y equals x squared minus 5x minus 6. In standard form, technically our A value is a 1 because there isn't any other numbers sitting there. Our B value is going to be this whole negative 5, and our C value is this negative 6. Okay, so keeping that in mind, since we do have an A value of 1, our approach is to take a look at the C value, which is the negative 6, and think about all of the factor pairs that would give you a negative 6. So it could be a negative 1 and a positive 6. It could be a positive 1 with a negative 6. It could be a positive 2 with a negative 3, or it could be a negative 2 with a positive 3. Any one of those pairs would multiply to give you a negative 6. Okay, so factor pairs of negative 6 is what we start with. Then we're going to decide which of those pairs add up to give us a negative 5. So if we add each of these pairs up, negative 1 plus 6 gives us positive 5. 1 plus negative 6 gives us negative 5. 2 plus negative 3 gives us negative 1. Negative 2 plus 3 gives us positive 1. So since positive 5 is the B value we're looking for, we are interested in this factor pair. So because we know that we just have a 1 for our a value, we can rewrite now as two binomials, factored form, with x's as the first term, because we know if we were to FOIL this back out again, x times x has to give us this x squared. Okay, so we know we need to start with x's. And then for the second term in each binomial, we can just use this factored pair that we came up with +1 and -6. And it doesn't matter which order you write these in. If you had done x minus 6 in the first parentheses and x plus 1 in the second parentheses, that is also correct. Because we are multiplying these two binomials, the order does not matter. So either one of these would be a correct factored form for the original standard form of y equals x squared minus 5x minus 6. Now, if a is not equal to 1, as you can see here, our a value is 2 this time, then we need to take a little different approach. So again, 2 now is our a, 11 is our b, and 5 is our c value. Okay, so instead of just looking at c, we are going to look at a times c. So the 2 times the 5 would give us a 10. And we're going to look at the factored pairs of 10. Now, this is the approach that I use. There are other approaches that you can use. And so if you're more familiar with something else and it consistently gives you the correct answer, that's fine. But this is a method that I think is very consistent. If you follow it, it works on any quadratic function that can be factored. And so this is the approach I'm showing you. So a times c, 2 times 5 is giving us 10. Now we're going to look for the factor pairs of 10. So maybe it's 1 and 10. Remember, it could also be a -1 and a -10 because two negatives will multiply to a positive. You could also be using 2 and 5 or -2 and -5. Now, similar to what we did in the previous example, we want to find the pair that adds to our b value. So we're going to add these up. 1 plus 10 gives me 11. -1 and -10 gives me -11. 2 plus 5 gives me 7. -2 plus -5 gives me -7. So the pair that adds up to my b value is this pair right here. Now, here's where it's very different. In the previous example, we would just use these in the parentheses. But here, we're going to use this factor pair to do what's called split the middle. And so what that means is that I'm going to rewrite my equation. My 2x squared for the first term stays as is. But then I'm going to rewrite the 11x as the two terms using this factor pair. So I'll have a 1x and a 10x. And then I add on my 5 to finish the equation. Now, the reason we do that is that we now have a function that has 4 terms instead of 3. And with 4 terms, I can group 2 and 2. So because of this grouping, one tip here is that we really want to try to keep a plus sign in between the two parentheses. It just makes things a little bit easier for our steps that are coming up. Okay, now in this case, that was easy because we're using positive factor pairs, and so keeping the plus there was easy. If you want other ideas on how to keep the plus there, refer to the worksheet. But now that I have these two groups of 2 terms, I can factor a common factor from each parentheses. So from my first parentheses, 2x squared and 1x have an x in common. So I'll factor that out and I'll be left with a 2x plus 1. I still have the plus sign here. And then in the second group, the 10x and the 5 have a common factor of 5. So I factored that out, and I'm left with a 2x plus 1. Now, at this point, you want to look at what you have in these parentheses, because they should match. If you're doing this correctly, your parentheses should match. And the reason we want them to match is because now we can factor out the parentheses. Just like we factored out the x that was in common or the 5 that was in common, we can now factor out the 2x plus 1 that is in common. And then our other parentheses will have the x plus the 5 that's left. Okay, and so that gives us our factored form. Y equals 2x plus 1 for our first binomial and x plus 5 for our second binomial. Now, quick note, technically, we haven't taken this value and brought it out as an a value. Most of the time, that's not really necessary. But if you did need to get a perfect match to what the factored form is, then you would just go one more step of factoring out the 2 from both terms in this parentheses, and you would get 2 out in front, and then you would have x plus 1/2 and x plus 5 if you needed a perfect match to the factored form. But usually this form is good enough. All right, how about changing from standard form to vertex form? Again, little different approach depending on whether a is equal to 1 or a is not equal to 1. So let's start with a equals 1. In this case, we are trying to get this into the form of y equals an a on the outside, an x plus or minus something on the inside, and then a k being added on the outside. Okay, and so we're going to use a method called completing the square to do this. And what that means is we're going to try to create a perfect square trinomial which we can then rewrite as this binomial square part of the problem, of the function. Okay, so how do we do that? Well, we start by putting our x terms, x squared and 6x, inside of the parentheses, and we leave some space. And then this -4, we're going to put out here on the outside. So now let's just focus on what's inside of the parentheses. Again, our goal is to get a perfect square trinomial, which means it's something that we can rewrite as a binomial square. So we can do that by looking at the b value, and we're going to take b divided by 2, and then we're going to square that. And that's going to tell us what we need to add in here inside of the parentheses to make that perfect square trinomial. So in this case, our b value was a 6. Divide that by 2 and square it. 6 divided by 2 is 3, and 3 squared is 9. Okay, so we need this 9 inside of the parentheses so that this entire thing inside of the parentheses is the perfect square trinomial. But here's the thing. I can't just go and add 9 to my expression and have it still be equivalent to what I originally started with. So in order to keep my function equivalent, I need to add something that is equivalent to 0. So if I'm going to add 9 to the inside of the parentheses, I need to balance that out and create a 0 by subtracting 9 on the outside of the parentheses. So overall, with these two together, the positive 9 and the negative 9 are really just a net addition of 0. Okay, so always remember to do that balance. Whatever you put on the inside, you have to balance that on the outside. Okay, but this gives us what we need now. We can now take this and we can rewrite that as x plus or minus something squared. Now, if you're not sure what that something should be, come back over to what you did here, and that something will always be just the b divided by 2 part of what you did here. So b divided by 2 was the 3, and so that's what we're going to add in our binomial. So this x squared plus 6x plus 9 is equivalent to x plus 3 quantity squared. And then we're going to take what's on the outside of our parentheses, we're going to combine those together, and we'll get our minus 13. So you can see we match this form. Technically, our a value is 1. Then we've got something being added or subtracted. So technically, h is equal to a negative 3 because it's minus the negative. And then our k value would be a negative 13. So we have matched this vertex form that we were going for. Okay, so again, our final answer is y equals x plus 3 quantity squared minus 13 in vertex form. Now, if a is not equal to 1, we have to try to rewrite our function in a way that creates a to be 1, because the completing the square steps only work when a equals 1. So we start out the same way as we did before. We're going to have y equals, we'll put the 2x squared and the minus 16x on the inside of the parentheses, leave some space, and then add our 9 on the outside. Now, we cannot use completing the square on those terms as they are because that a is not equal to 1. So we have to do one more step before we can make our perfect square trinomial, and we have to factor the 2 out of just these, just these 2 terms in the parentheses. Okay, so both terms, leave your space, but that factoring does not affect what's on the outside of the parentheses. So it's still just a plus 9, but we have divided this 2 out of both the 2x squared and the negative 16x. And now what's left inside of your parentheses does have an a of 1, and you can use your completing the square steps from the last example. So again, b over 2 quantity squared means we're taking a -8, remember to keep that minus with it, over 2 quantity squared. That's a -4 squared, which is a 16. So we are going to add 16 inside of the parentheses in order to create the perfect square trinomial that we need. Now, before we go subtracting 16 on the outside, stop for just a second. Because remember, this 2 is being multiplied by everything inside this parentheses. So we did not just add a 16, we really added a 32 to create this perfect square trinomial. So the balance on the outside is not a -16, it is a -32 in order to create the net effect of 0. So that's where you have to be really careful when a is not equal to 1, is in that not only factoring that number out in one of the first steps, but then also remember to multiply it when you're doing the balance. Okay, and so now we've got our y, we've got the 2 out in front. We're going to rewrite x squared minus 8x plus 16 as x minus 4, because remember, b over 2 is -4 squared. And then we'll combine our 9 with our -32 to have a minus 23. So here's our a value, here's our h value of 4, and here's our k value of -23. Okay. Last but not least, if we're trying to go between factored form and vertex form, really the only way you can do that is to take and change to standard form first. Whether it's factored to vertex or whether it's vertex to factored, you're going to have to change it to standard form first and then use one of the previous steps to get it to the other form. There is no direct way to go from factored to vertex. Okay, so if I want to change this example, where I've got a factored form of 2x plus 1 times x minus 2, if I want to change that into vertex form, the first thing I need to do is to FOIL. So 2x times x will be a 2x squared. Our outsides give us a -4x and a positive 1x. For the insides, then we've got our lasts giving us a -2. So y equals 2x squared minus 3x minus 2. And then we go through the process of changing from standard to vertex. Now, in this case, the reason I wanted to show you this particular example is this one gets a little bit tricky, but the steps don't change. We just have to be very careful about how we do the steps. Okay, so first thing we're going to do is we're going to factor out that 2. We'll have an x squared minus a 3/2 x on the inside of the parentheses, and then we'll have the -2 on the outside. Okay, so remember the 2 has to be factored out of both the x squared and the x term. Now you could make that 1.5 if you prefer decimals, but I kind of like fractions in this, so I'm going to leave it 3/2. Then we go through the same steps of taking b over 2 and squaring it. So if I take 3/2 and I divide by 2, that's the same as multiplying by 1/2. So I'm really looking at 3/4 squared. So I've got 9/16. So that's what I need to add on the inside is 9/16. But again, remember that's getting multiplied by 2 here. So if I take 9/16 times 2, I'm looking at 9/8. So that's what's going to get subtracted out here for the balance. Okay, everybody see that? So here's b divided by 2 squared. That got us the 9/16. And then the 2 times the 9/16 is going to give us the 9/8, which is what we need to subtract out here to balance. Okay, whoops, try that again. There we go, sorry about that. All right, so let's get rid of some of this so that we can keep moving a little bit. Sorry, not sure why this is being so touchy. Okay, so we're good here. Yes? So from here, we are going to have y equals 2. We've got x. Let's see, this was actually a -3/2. So that was a -3/4. So minus 3/4 quantity squared. And then our 2, we could rewrite as in eighths, that would be 16/8. So -16 and -9 is going to be -25/8. So that would be our vertex form. Okay, so notice all of the steps are still the same as what we talked about in a previous example. They're just a little bit trickier because of the fractions involved. But if you're careful, you can still do it. Last but not least, if we go the other way from factored form to vertex form, again, our first step is going to be to change into standard form. So x minus 4 squared is going to be x squared minus 8x plus 16. Then we have the -1. So we're looking at y equals x squared minus 8x plus 15. And then from there, we can go to vertex form. I'm sorry, we can go to factored form. Since we have a 1 for our a, that means we're just going to think about factor pairs of 15. So that could be a 1 and 15, or negatives. That could be a 3 and a 5, or negatives. And if we add those together, this will give us 16. This will give us -16. Here we get an 8. Here we get a -8. Our b value is -8. So this is the combination we want. And so we are now looking at y equals an x minus 3 times an x minus 5. And there's our factored form. All right. So I hope you have found this helpful. If you would like to see other concepts that you need to refresh or review, please check out my Gordon Global Math YouTube page. Videos covering Algebra 2 and pre-calculus concepts will be added throughout the spring of 2025. Thanks for watching.